Hello, my dear children. Good morning, you all. Now I am going to continue my this topic, some name reactions. You know that there are various organic reactions which are based on the name of various scientists. In my previous lecture, I was already discussed about the various name reactions. Now I am going to continue some special name reactions which are important at the point of your course and for your knowledge. Here I am going to discuss about the first one, Reimer-Tiemann reaction. What is Reimer-Tiemann reaction? In this Reimer-Tiemann reaction, this reaction belongs to phenol. When phenol is heated with chloroform and caustic soda solution, it forms salicylaldehyde. This one is salicylaldehyde. This CH forms CHO, and 3Na and 3Cl combines together to form 3NaCl with 2H2O. This compound is orthohydroxy benzaldehyde, or you can say salicylaldehyde. This reaction is known as Reimer-Tiemann reaction. In this reaction, phenol gets converted to salicylaldehyde or orthohydroxy benzaldehyde. If we want to prepare orthochlorobenzaldehyde from phenol, then first of all we treat phenol with chloroform and NaOH to get orthohydroxy benzaldehyde, and then like this, phenol with chloroform and NaOH gives orthohydroxy benzaldehyde, and if we want to form orthochlorobenzaldehyde, then we react it with PCl5, which forms here Cl, CHO. This one is orthochlorobenzaldehyde. In this way we can get orthochlorobenzaldehyde from phenol. These reactions also help in conversions. How will you convert phenol to salicylaldehyde? Or anyone asks you phenol to orthochlorobenzaldehyde. In this way we can convert this one. Second reaction, these are the various very important reactions which are related to your course. Second one is another reaction, that one is Kolbe's reaction. What is the Kolbe reaction? Kolbe is the name of scientist. In this reaction, phenol, this reaction also related to phenol. In this reaction, phenol, first of all, react with NaOH to form sodium phenoxide, ONA. This one is sodium phenoxide. And this sodium phenoxide on reaction with carbon dioxide forms OHCOONA in this way. This one is orthohydroxy sodium orthohydroxy benzoate, orthohydroxy benzoate, or this compound is also known as sodium salicylate, and on acidification it forms salicylic acid, COOH, orthohydroxy benzoic acid, or you can say it salicylic acid. Salicylic acid. This one is very medicinal use. It can be used for various medicines and various purposes. This one is Kolbe reaction. Now I am going to discuss about the third reaction which are related to your course, and that third reaction is, I think, Williamson synthesis. Williamson synthesis. Yeah, Williamson synthesis. Williamson synthesis. This reaction is used for the preparation of ether or water. Ether is prepared by this reaction. In this reaction, alkyl halide is treated with sodium alkoxide. Both can be different or both may be same. This one is alkyl halide and this one is sodium alkoxide. On reacting this, it forms ROR. This one is ether and this Na combines with X to form NaX. This one is ether. Means both symmetrical and unsymmetrical ethers can be prepared by this method. Both symmetrical and unsymmetrical ethers can be prepared by this method. We take an example, C2H5Br bromoethane, or you can say ethyl bromide, with C2H5ONa sodium ethoxide. It forms C2H5O C2H5 plus NaBr. This one is diethyl ether. Here, a very important point to note in your mind: tertiary ethers are prepared by this way. This one is sodium tertiary butoxide. Why this is called tertiary? Because this carbon is bonded with 3 other carbon atoms. And CH3Br, tertiary alkoxide is used for the preparation of tertiary ether. CH3, C, CH3, CH3 and OCH3 plus NaBr. This one is methyl tertiary butyl ether. Tertiary ether is prepared by using this way. If we use tertiary alkyl halide at the place of this, like this one, Br, this one is tertiary butyl bromide with CH3ONa, alkoxide is primary, then Na and Br combines to form NaBr, and this CH3O minus act as a strong nucleophile and it releases hydrogen from any of the carbon and form alcohol CH3OH. Means here elimination takes place, means the product will be like this. Alkene is produced. Here no ether is produced, alkene is produced. This is the difference between this and this reaction. It is a very important topic, keep in mind. Next, I am going to discuss about the, I think, after this, I am going to discuss about the Cannizzaro reaction. Cannizzaro reaction. What is Cannizzaro reaction? This reaction is shown by those aldehydes which have no alpha hydrogen. Means the aldehydes which do not have alpha hydrogen give this reaction, like formaldehyde, benzaldehyde, etc. Those aldehydes which have no alpha hydrogen give Cannizzaro reaction. In this reaction, when the aldehyde is heated with caustic soda solution, one molecule of aldehyde gets reduced and another molecule of aldehyde gets oxidized. One molecule gets reduced to corresponding alcohol and another molecule gets oxidized to form sodium salt of carboxylic acid. This reaction is known as Cannizzaro reaction. This one is formaldehyde. Formaldehyde on reaction with NaOH gives methanol and sodium formate. Methanol and sodium formate. In this way, if we use C6H5CHO, this one is benzaldehyde, and benzaldehyde on reaction with NaOH, one molecule get reduced to form C6H5CH2OH. This one is benzyl alcohol, and another molecule get oxidized C6H5COONA, sodium benzoate. In this way, we get corresponding alcohol and as well as sodium salt of that compound. This reaction is called Cannizzaro reaction, and this reaction is shown only by those aldehydes which have no alpha hydrogen. Okay. In my next lecture, I will continue about some more reactions. Thank you.